Hey guys, welcome back to AlgoYogi. Now we are doing graph series, and our next problem in the list is island perimeter. Let's go to LeetCode, give this problem a read. So you are given row into column grid representing a map where basically the value at grid ij1 represents land and value 0 represents water. Grid cells are connected horizontally and vertically, not diagonally. The grid is completely surrounded by water. Alright, so this everything right here, this is water, this is the grid. This brown square means it's a land, and in our grid this will be 1. And this blue grid means it's water, and that will be 0. Now this island doesn't have lakes, so it does not have any water body inside the land. Okay, now meaning that water inside isn't connected to water around the island. I mean, that's, of course, we understand that. Now one cell is a square with side length 1. The grid is rectangular. Width and height doesn't exceed 100. Determine the perimeter of the island. All right, so straightforward, very simple. Here is your island surrounded by water. So they're saying like there will be an island here, just one island, and now we need to find the perimeter of this island. So rest everything around this is just water. This is my grid, and this grid has basically two types of values. One is ones and another is 0. So this is all 0 1 0 0 0 1 1 1 0 1 1 1 0 0 0. So now we have to consider all these ones grids and just find out the perimeter of this grid. So basically this is the border, this is the border, this is the border, this and this, then this. So everything, if I just cover all of it, and this length is 1, so there are 16 of these borders, so the answer will be 16. So 16 will be the perimeter of this island. Remember that it's not just visiting each grid and just like adding 3 or 2 or something like that, because remember this is also a grid, but its border is not counted because it's only surrounded by land. So this is not going to be considered as border. The only border that will be considered is that's basically touching the water, or it's out of the bound. So basically this is out of the bound, or it's touching water. This and this. So now let's go. How are we actually going to find out the complete perimeter of this island? Now the brute force way of finding it would be just iterate over the entire grid, and whenever you come across a land, so let's say this is my land right here, so this is my land. Now what I'm gonna do is I'm gonna check all its sides. So if either its side is out of bound, that means that has to be the border. If I'm visiting, it's part of the grid, and if it is equals to the land, which is 1, then I'm gonna check its all sides. So basically this right, left, up and down, I'm gonna check is this out of bound. If it is, so I'll basically, this should return 1, this should return 1, and if this is water, then also it should return 1. If it is land, then only we return 0. Okay, so that once, okay, I'm gonna do a little iteration here. So let's say I come across right here, so this will basically get 3 values from around it. So 1 from here, 1 from here, 1 from here. Then these are basically zeros, so I don't consider them. Then I'm gonna go over here, then I see, okay, this side is water, This side is water, so I'll get 1 from this side, 1 from this side, and 1 from this side. So 3 will be here. Then this has land all the sides, so this will have 0. Then this will have 3, this will have 2, this will have 2, and this will have 3. So the total would be 16. So using 2 for loop, we're gonna traverse this grid, and then whenever you see a 1, then you check its border. Either there will be other these values, either they are 0 or your row and column is going out of bound, so you will still add that as 1 to your perimeter, because that's also border is also perimeter. All right, so now that's the brute force way of doing it, but I know this problem is basically a foundation to a very important problem, which is finding number of island. So we will be solving this problem using the graph concept. So we will be using the graph traversal methods, which are depth first search, DFS, or BFS. But in this case, we'll be using DFS, and let's see how we are actually going to approach it. So we'll start iterating the grid using that for loop method, two for loop method. So let's say this is of length, this is column length, so let's call it C. Let's call it C. Then this is row length. Let's call it row of the grid. Then we are going to have a visit set. We're going to have a visit set. This visit set will basically contain all the nodes that we have visited. All right. So like for the simplicity, I'm just gonna call these nodes. Let's say I'm gonna call it A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. This will make our things super easy. Okay, so let's say I go to basically the first, while visiting, I go to A, and then I see that this is actually 0. It has the value 0, so I'm just going to ignore it. So I'll go to the next one. Now this B node, it has 1 here. So I'm interested in 1. So what I'll do is I am going to add this. I'm going to basically call DFS function on it. So I'll have a DFS function. We will implement it, but let's say like what that function is going to do. So that will basically make calls to all the neighboring nodes beside it, basically on top, left, right, and bottom. So this is how it will be calling all the nodes. And basically now we'll have a base condition where if either this is out of bound, so this is out of bound, this side is out of bound, this grid is water, so whatever grid is water, we or it's out of bounds, or it's been visited, then we will return 0 if it is already visited. But if it is out of bound, or it's basically the neighboring grid is water, then basically we need to consider that as border, so we will return 1 from that side. So these will be returning 1 to B, but this land, because this is a land, F is a land, so F will be basically making DFS calls to its neighbors. So like this, and this. So it will be making call to D, G, and J. And because J is a land, it will be making call to N, and because N is a land, it will be making call to M, and M will be making calls to its neighbors. Remember, this N is also making calls to these sides, but remember we are only going into DFS for the land part. Okay, we are considering we are trying to find the border of the land, not the water. But these water bodies, they will, if we are seeing like on my left or right or top or bottom, wherever, if I have a grid that is water, then it will be returning 1 to me. So you will see there's all these sides. Let me clear this up and let's make things super simple for us. So what I'll have is, I'll go to this grid. Let's say I'm gonna call it, let's say I came to this grid and I'm gonna call it like A. Let's call it A. So I was at A. I'm gonna add A to my visit set. Then it is gonna receive 1 from all these sides. So it will receive already 3 here, but then it made a call to this grid. It made a call here, 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 and here. Then this piece will receive the value 1, 1 and 1 from all these sides. So it will have 3, it will have 3. Now this 3 it will return back over here. Now this should be receiving 1, 1 from these sides, so this will receive 2 plus 3, so it will give back here 5. Now 5 should receive basically 1, 1 from these two sides, so it will have basically 7. It will return 7 here. Now you can already see 3 coming from these two sides. It will have basically 3, which is 3 from this side, 3 from this side, so it's going to be 13. 13 plus 3, that is our answer, 16. All right, and remember that when we are visiting these, we'll keep adding them to our visit set. We'll keep adding. We're gonna deal with the grid, so we don't have to worry about, like, you know, how we were understanding this using ABCD. But remember, we'll be using the rows and columns to track like what node that we have already visited, because so that we don't come across these nodes and stuck in a loop. So let's write down the code. It's going to be super simple. This is the easy problem. It's an easy side, but it's actually a little time taking. Yeah, you can tell that. Okay, so first thing first, we're going to have a visit set. Visit set, it will be a set. Then let's calculate the rows and column length. So that will be the length of the grid rows, and then length of the column will be basically length grid, but let's choose the first row, so that will be the column length. You can tell that. So grid 0. All right, so now what do we do? Let's have our function for I in range, or you know what, why not use R row for R in range rows, for C in range columns, if the grid has 1 in it, that's when we are interested. So if it is equals to 1, then only I'm gonna make call to my DFS. So, or maybe, you know what, I'm just gonna return DFS here. I'm going to send in, because there is just one island, so we can safely return this. Otherwise we can return 0. All right, we can return 0. Now let's implement this DFS. So it's taking a row or column. So whenever we came across the land, now we're gonna traverse the entire land. So it's just like, you can imagine it like in reality, that you were in the water and you found just like one side of the land, and now you want to just like take a walk on the entire land, right? So what we'll do is, like, we'll have a DFS, and let's have a base case. So if R is less than 0, or C is less than 0, so which means we're checking the bounds, or R is greater than or equals to big R, basically it's going out of bounds. For column also, let's check. So if it's greater than or equals to C, or it's actually water. So grid R and C, this is equals to 0. So in any of these cases we return 1. Remember, if this is actually, if this particular this is in visited, if it's already in visited, that means we actually return 0, I guess, right? Or do we even need to consider it if it is 1? I'm just thinking. But anyway, let's check if R and C in visit set, then we are gonna return 0. Okay, we're gonna return 0, and then we're gonna also add this to visit set. So set dot add, and let's add this R and C to my visit. Now what is the case that's left actually now? So you're checking if it is in visit set, then you return 0, otherwise you return 1, but now and then you are also adding it to the visit set. There is just one condition that's left, which is if it is actually, this grid is actually equals to 1. That means it's moreland. So what does moreland mean? Moreland means we're going to return, so let's say perimeter equals to DFS, and we're going to call DFS on basically it's all the 4 sides. So let's call it on all the 4 sides, which is C plus 1. We're going basically to right. Let's go to left. So C minus 1, C minus 1. Let's go up and down also. Go up, R plus 1, and then sorry, this is we're going down here, but let's go up. So you're gonna reduce the length of the row. So I'm combining all the border that's they're gonna bring with them, the border values. So this is R minus 1. All right, and then finally we can return. Finally, we can return perimeter. Awesome. So this is our entire code. I'm just gonna make it a little cleaner so that you can see all of it. Okay, that's our entire code. Now let's run it on our example. I am gonna zoom out. I hope we didn't make any mistakes. Just little syntax error right here. That's not how you do in Python. You're gonna have over here. Okay, let's now run it on our examples. And I guess that is it. All right, submit. And let's write down the time complexity and space complexity. So I'm gonna say time complexity is going to be big of R into C, row and column. This because at the end of the day we are visiting, so you can see this DFS, this DFS being run, and this it's gonna have some stack space also, but the thing is at the end of the day we have R into C grid, and we are definitely visiting all of those, or maybe not all of those actually. So we will be, once you find the found the edge of the island, wherever, you're gonna basically traverse the whole island and return this. Okay, so but safely we can say this is the time complexity, and space complexity could be actually all the, I'm gonna call it I, and I is the number of oh no, it's gonna be R and C because of our visit grid. Okay, R into C. That's it. This is safe way. Now let's go back to AlgoYogi, mark this problem solved. See you guys later in the next problem. Until then, bye bye.